says you can sell, here's the amount of forest that is available to be bought and sold in America. So fixed supply, and that would define there'd be some market price. And then maybe the government comes along and says, all right, we're considering a policy to put a chunk more forest land on the market. And this demand curve, if we'd actually gone out and estimated it by asking people their valuation and aggregating up, right? You know that you ask people their individual valuations, their demand curve, and then you sum horizontally to get the aggregate demand curve, and we would be able to predict, right, what the new equilibrium price would be, P prime. We could get a little bit political on the thing and say this actually is Yosemite. So let's say we're considering expanding a national park or national forest. Having mapped out this demand curve, we could actually predict how big of a tax increase people would be willing to vote for in order to protect more of Yosemite Park, right? That's sort of then putting your money where your mouth is. So that's all positive economics. Oh, that's right, this is the problem with getting creative in your slides. Now, what about the normative dimension of this thing? This is about putting a value on things. That's not the same as the price. It's the question of how much is this actually worth to society, right? So, for example, suppose we were in this private market again. We have this policy where we're going to expand the fixed supply of forest that's available for trade. We might want to know, here's the price. This is sort of the resale value of the land that people already owned. How much of that resale value did they lose, right? You could argue that strictly in dollar terms, but it's a way of using the model to put a dollar value on something that otherwise would be very hard to value. More relevantly, we could ask how much, so these are the new units, these are new owners, and this piece here, as you know, would be the additional sort of consumer surplus that they generate, that they get as a result of having been able to purchase this newly available forest land. So this is all about placing a value, right? That would be the value of the impact of making this forest land available. And indeed, this is precisely what economists do in the real world when they're trying to advise policymakers on this kind of policy. And we could simultaneously ask, if we were to go ahead and protect pristine forests with or without a simultaneous tax increase, how much would we make society better off? Would it be a good idea? Would that number be positive or negative? If we protected forest land versus going over here and protecting desert land, which would be better for society, etc. Okay? Now, let's now talk about the standard model. And this should all be reviewed. The standard model tells us where this demand curve comes from, right? So what I have here, besides my taskbar, what I have here is classic sort of progression of graphs that I'm sure you've all seen probably too many times for your own comfort, from the indifference curve to the demand curve, right? So we have this idea, by the way, in the history of microeconomics, if you go back to Valras, who's the English guy? Marshall. They postulated a demand curve without this indifference curve. They just said, look, you can see that when the price goes up, people are going to buy less. And then other people came along and said, great, let's put some theoretical underpinnings under that, what are referred to as micro foundations. Okay, so this is the standard model of the micro foundations of the demand curve. So you have an indifference curve, which is a cross-section of a when we get to where we can all sing this song in unison. An indifference curve is remember the utility mountain, right? It's a cross-section of a utility function, okay? So we have two goods. It could be any two goods. You've probably seen things like rice and beans or guns and butter. In this case, we're doing one good is acres of wilderness forest land in units of 100 acres, and the other is the sort of composite good, which we call dollars, right? It's everything else you could do with your budget, okay? And we have this idea that there's a utility function where I can plug in the number of units of forest you get and the number of units of money you get in an endowment and say, okay, this indifference curve is sort of like as I add, right, if you imagine that thing on this plane, as I add acres of forest land or money, you go up the utility mountain, your utility level goes up. And then I can move you along this indifference curve by taking away a certain number of acres of wilderness forest and giving you money instead, or vice versa, and your utility will stay constant. That's the definition of an indifference curve. And then that allows us to start moving towards the demand curve. This is, right, okay, so I'm going to jump off a cliff really soon. Okay. The thing that's of primary interest in this indifference curve is its slope. The name for the slope of an indifference curve is the which of a what? The who? The marginal rate of substitution, okay? The slope, right, is how many units of thing 1 would you be willing to give up in exchange for one more unit of thing 2. So as you substitute from one another, what is the marginal rate at which you substitute in order to remain indifferent to the trade? Okay? So the slope is the MRS. And the MRS, if you remember from the implicit function theorem, it is the ratio of the marginal utility for good X, that's in this case acres of wilderness, to the marginal utility of good Y, which in this case is dollars. Okay? So it's the ratio of how much additional utility you get from an acre of land to how much additional utility you get from $1. All right? Now, that, you don't have space on the slide for this, I'll just put it on the board. So the marginal utility of X over the marginal utility of dollars, marginal utility, right, is the partial derivative of the utility function with respect to good X, and then we're going to divide that by the partial derivative of the utility function with respect to dollars. Okay? Now, this is abusive notation, but it is conceptually valid. We can then just sort of treat this as if it was a mathematical expression, and we wind up with that being equal to the partial derivative of dollars with respect to good X. Okay? That is dollars per acre, right? That's willingness to pay. How many dollars per acre are you willing to exchange for forest land? So the slope of this thing is your willingness to pay. Key point, if you're going the other way, right, if I'm taking away forest land, then the question is how much money do I have to give you, right? And so this exact same ratio in this model is equal to willingness to accept. They should be the same. This, for the purposes of the next couple of class periods, is the key point, okay? That slope is the same whether you're going infinitesimally one way or infinitesimally the other way, right? So here's how we get to the demand curve. Again, all review. We start by sticking in a budget constraint, right? And the slope of this thing is the negative of the price, the inverse price ratio, right? So we'll call this the budget constraint for some price P naught. So the slope of that thing when good Y is dollars, the slope of that thing is negative P naught, but we just focus on the price itself, P naught. Then we get this point of tangency, right? The maximum utility that you can achieve on that budget constraint is where the indifference curve, right? You could have a map of indifference curves going up like the contours on a map. We want to pick the highest indifference curve before we leave the budget constraint. That's a point of tangency. And what that allows us to do is it allows us to map out how much of good X you would choose in your bundle of goods, in your allocation of money, or your budget rather, at a price of P naught. And then we can go over to the second graph, and we can say, all right, let's just stick P0 on here somewhere, and we'll stick X. This is obviously not to scale, and we can just map out these 2 points. Okay? And that gives us a point on a demand curve. Right? That's where the demand curve comes from in the standard model. Now, this is a little bit, I'm sort of bastardizing the model a little bit here. So starting at any point, P, X of P, if you make infinitesimal changes in price, right, at the margin, you're moving along the same indifference curve. Now, obviously, if you make a big change in, a non-infinitesimal change, well, this is calculus, everything's in infinitesimal terms. If you made a quantum increase in price, you'd be moving up or down to a different indifference curve. But at the margin, you're essentially moving along the same indifference curve, which means that you're moving from one sort of, if I were to move XP along, if I was to move the price up or down infinitesimally, I would be moving you infinitesimally up or down on the X scale, right? So the point of that is simply to say that if this model here is correct, then what we're looking at is a continuous demand curve that is the same in either direction, right? As I increase the price a tiny little bit, the quantity that you'll be willing to demand, or to buy or sell, or vice versa, as I change the quantity a little bit, your willingness to pay will move only infinitesimally, right? So infinitesimal change in price, infinitesimal change in the height of the demand curve, the horizontal dimension of the demand curve, which means that as we move away, all right, I'm going to have a conversation with Bill Gates about this, which means that as we move away from this point, we're going to be moving continuously in either direction, not jumping, okay? It also, if you look at this graph, it also tells us that it doesn't matter which direction we move in, right? The slope of this indifference curve right here tells us both your willingness to accept payment for one less unit of force and your willingness to pay for one more unit. Willingness to accept, willingness to pay the same thing, which is to say that once we've mapped out this entire demand curve, it's going to be the demand curve whether you're buying or selling, right? And it's going to be the one that it's going to be your only demand curve. There's only going to be one demand curve, okay? This explanation here, I'm not going to fuss with too much. I'm not particularly thrilled with that explanation, but I said it in words and I like the words I said. Now, I'm going to call Waldo back, and we're going to take a look at what the demand curve for Forrest might look like for the people in this room, minus me and Waldo. So, you got some numbers for me?
Yeah, so I guess.
Hang on, I'm just going to, don't say it out loud. Let me have your pen real quick. Just write them down. So for group 1, what do we have? Okay, and that was group 1, and for group 2. Great, perfect. I'll come back to that. You know what? I love this exercise. It works every time. I'll give you that back. I'll give you that back in a second. Okay, so for group 1, and this is a rough cut, right? Because I just did bins, pretty large bins, and then the top one was there was like no upper bound. So this is not perfect. But just taking the midpoints of each of those bins on A through E and multiplying, weighting based on the percentages of you that gave one answer or another, group 1 had an average willingness to pay for acres, or valuation rather, of forest land of about $240. Okay. Group 2, it was 573. Now, you can probably see where this is going, right? I'm no magician. You can see all the cards in my hand, so you can probably see where this is going. Let's take a look at the different scenarios that you guys got. Group 1, the National Park Service is considering purchasing a 100-acre region of pristine forest adjacent to the edge of Yosemite National Park to prevent it from being used for industrial development. The development would involve clear-cutting the forest and paving most of the region. And then you're being asked, what sum of money would you be willing to pay? Okay? Group 2 was asked a similar but different question. NPS is considering selling off a 100-acre region of pristine forest for industrial development, blah, 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 blah. How much money would you be willing to accept in exchange for allowing the NPS to sell the region to the developer, right? So in these United States, we have the idea that the residents, citizens, taxpayers, however you define the body politic, actually owns these sort of public properties or has some right to them. So the question you're being asked is, what would be your willingness to accept payment to give up some of your precious Yosemite versus how much you'd be willing to pay to expand it a little bit? And I can tell you that the results work when you're talking about national parks in India, because I tried that with a group of visiting scholars from India, and it's a very robust result. So what would that say about what we're looking at here? Okay. Well, first of all, I would say that my writing is too big. 573. So for group 1, this is the willingness to pay for an additional 100 acres of forest. So let's suppose that we are here at X, where X equals the area of Yosemite. I wish I knew what that was, but I don't. So for group 1, right, their willingness to pay is in here somewhere, $240 for group 2. So this is, right, at that point, the height of the demand curve is your valuation for one more or one less, right? So I'm assuming that the number of acres of Yosemite is like into many tens or hundreds of thousands of units. So this is just an infinitesimal increase or decrease, and for group 2, it's up here at 573. Now then what we could do is I could then go, and for those of you who are selling off Yosemite, I could sort of incrementally destroy Yosemite unit by unit and ask you your willingness to pay for each unit. And presumably, as Yosemite got smaller, you would express a higher willingness to pay, right? That's the point of the demand curve, is it's downward sloping. And vice versa, for those of you who are being asked to expand it eventually, you'd say, wait, yet another 100 acres? Yosemite is now covering all of Nevada and Northern California. I'm really not willing to pay much for one more unit. So we would imagine some kind of downward sloping demand curve like this, which, if you make your dots big enough, would go through the actual line, the actual dot, okay? And what we have here is suggestive evidence that there are actually 2 different demand curves in existence for wilderness forest. So this is, I'm trying to get as quickly as possible to sort of like the basic idea of, here's a standard model that has the following implications. There should be one unique demand curve for any population for any particular good. And here we have evidence to suggest that if we know what we mean by willingness to pay and willingness to accept, and if you guys have, a basic comprehension of your preferences for forest land, this violates the standard model, right? The standard model can't handle this. It doesn't predict it, it can't explain it, it doesn't fit. So we call that an anomaly, right? It's a puzzle if you want. Now, in terms of positive economics, predicting what will happen, this isn't actually such a problem, right? In fact, this is great, because now that we know this, basically, in terms of positive economics, we can still predict, if these are reasonably good estimates, we can still predict what will happen. We just have to know, are you in the position of giving up land, or are you in the position of acquiring more land? And if you're in the position of acquiring more land, we'll use this demand curve to predict your behavior and the aggregate behavior of society as a whole. And if you're in the position of giving up land, we'll use that one, okay? For positive economics, this is not that big of a challenge. It's not that big of a problem. But for normative purposes, this is now a big problem, right? Because we're in the business as economists, particularly in the realm of public policy, of saying that the height of the demand curve represents how much things are worth to society, and we no longer know the correct answer. yeah, so this is just to give you a sense of how sort of gonzo and meaningless and nonsensical this is normatively. Suppose you had a policy of first providing people with an additional acre of wilderness without necessarily making them pay for it, just providing it, and then taking it away again, right? I'm going to preserve this wilderness here, it's yours, now I'm going to take it away. I've made you worse off by just giving it to you and then taking it away, right? Because when I gave it to you, it was only worth as much as the height of the lower of these two curves, and then when I took it away from you, suddenly you valued it more. And so by just giving you something and taking it away, I made you worse off, right? Most public policy decision makers would not be particularly interested in that analysis, because it's kind of vacuous. Like, what does that even mean? In fact, to take it to extremes, you could imagine a policy of giving people extra something or other, some extra public good, taking it away again, then you wait a little bit, give it back to them, and then you take it away again, and then you give it back and you take it away again. Now, if you do this to a cat, they're eventually going to go insane. But you can see that in material terms, this policy is not changing society's endowment. But if this is correct, then you could actually destroy the entire value of societies. Like you could destroy all of the consumer surplus on the planet by simply giving people an acre of wilderness and taking it away again. Right? So obviously, this is obviously absurd, and this is a huge challenge normatively for the standard model. And it's not just a challenge normatively for the standard model. It's a big problem for economists who are trying to do normative analysis, right? Because we no longer have firm ground under us. It also means that, so where people actually use this kind of thing, by the way, the hypothetical thing I just did to you guys is a simplified version of something that is real in the policy world. It's called contingent valuation, or CV. So what I just did was I conducted a contingent valuation survey. It was a very rudimentary one, but the results are exactly the same as if I had done it in a much more scientific and rigorous way. People do this all the time in environmental economics and lots of other areas of economics. It's in many cases the only way to try to put a dollar value on public goods. And what happens is that there winds up being huge controversy about which number to use, right? So this is, we're thrown into this, this huge problem normatively. We don't know what to do. Yeah. Utility is what we're thinking of. We've used this methodology to put dollar numbers on the utility. So you gain utility when I give you the land, you lose utility when I take it away. And what this is saying is that the amount of utility in dollar terms that you get when I give you the land is less than the amount you lose when I take it away. Now, by the end of the class, you're going to see this happening in a much more tangible way that will make it more obvious what's going on psychologically as well as economically. Yeah.
Can't they just weight it by first take a sample of how people feel they have ownership or not, and then weight their answers by that?
So in other words, just take seriously, these people are in fact owners that they're giving up stuff. So that's one of the things that people try to do. But in aggregate, we're just trying to decide some policy about how you feel about Yosemite. Everybody's in the same boat with respect to Yosemite, right? So it doesn't, it's like just basically depending on how we phrase the question, we can get a different answer. Okay, yeah. In this super simplified way that I did it, maybe so. But the sort of field, there's a whole field in environmental economics of people who study how to do this better, and they have much more sort of rigorous and careful ways of asking you the question that would rule out that kind of explanation. It's trying to capture the dollar value of the utility that you get from having certain public goods. Could be a stadium, could be street lighting, could be wilderness, it could be a road, any kind of public good. Okay, okay, we've seen that. So now let's just look at, right, so one of the things we have to do when we're trying to challenge the standard model is we have to actually make sure that we can rule out all possible explanations that the standard model might offer. So to tee that up, let me ask you this clicker question. What is the calculus definition of a normal good? Okay, i.e. the definition in terms of derivatives. And what does that tell us about the income effect, right, i.e. the effective income on demand? So recall in the context of the simple two-good model you learned in 100A, demand for good X can be expressed as a function of the price of X, the price of Y, and your income. Okay, so here are 4 different mathematical expressions, or inequalities rather, in different definitions. So I'm going to turn this on. I'll give you 30 seconds or so. So this is just to yourself, not with your neighbors. Again, I'm not giving any points for getting it right. That's why there will always be a no answer option. Okay, let me give you maybe about 10 more seconds. I think that there are a decent number more than 100. I guess some of you don't have clickers yet. Okay, 5, 4, 3, 2, 1, and we'll stop. All right, so what do we come up with? Aha, good. So what this tells me is that by and large you have taken seriously my admonition to not take this class if you haven't taken 100A, and that you guys are smart and you remember what you learned. The answer is A. Would somebody who gave that answer like to explain what it means? What does the derivative mean? What are we talking about here?
So the derivative symbol means the change in X given a change in I, so change in the quantity of X purchased given a change in income. So for a normal good, you purchase more of that good, you have more money. So when income goes up, again, also goes up.
Okay, so that derivative should be greater than 0. You nailed it. That's